For 36 years, scientists knew something was happening on Neptune that no telescope on Earth and no spacecraft in orbit had ever actually managed to see. They had the prediction. They had the theory. What they didn't have was proof until the James Webb Space Telescope finally pointed its instruments at the most distant planet in our solar system and captured something nobody had ever successfully photographed before. And buried inside that same set of observations was a second discovery, one that stunned even the scientists who found it. Neptune, a planet already so far from the sun that sunlight takes over 4 hours to reach it, has been quietly, dramatically cooling, its upper atmosphere now measuring only half as hot as it was when we last got a close look. Tonight, we're looking at what Webb actually found when it captured the clearest images of Neptune ever taken. Why one of astronomy's? To understand why this moment matters, you have to go back to the only other time humanity ever got a close look at Neptune. On August 25th, 1989, NASA's Voyager 2 spacecraft became the first, and until Webb, only real close-up encounter with Neptune, passing within about 3,000 miles of the planet's cloud tops before continuing on its permanent journey out of the solar system. Voyager 2 gave us our foundational understanding of Neptune, its winds, its faint rings, its strange, tilted magnetic field offset. A full 47 degrees from the planet's actual rotation axis, unlike anything found on any other planet in the solar system. That flyby also gave scientists their first real evidence that Neptune, like Jupiter, Saturn, and Uranus before it, should be producing auroras, the same glowing curtains of light that appear near Earth's poles when charged. Particles slam into the atmosphere. For 36 years afterward, despite repeated attempts using nearly every major observatory available, nobody could actually capture and confirm an image of Neptune's aurora. It remained the one missing piece in an otherwise complete picture of aurora activity across every giant planet in the solar system. Think about what that gap actually represents. By the early 2000s, astronomers had already confirmed auroras glowing at the poles of Jupiter, Saturn, and eventually Uranus, building a complete, consistent picture of how charged particles interact with the magnetic fields of every giant planet in our solar system, except one, Neptune sat. There for decades as the obvious exception, the missing entry in an otherwise tidy scientific catalog. Its aurora predicted with confidence by every model astronomers built, yet somehow never actually observed. It became one of those quiet, long-running mysteries that never made headlines the way a new planet or a dramatic collision might, but that nagged at planetary scientists for an entire generation. A prediction confidently made in 1989 that nobody could actually confirm for 36 consecutive years. That changed in June 2023 when a research team led by Henrik Mellon, an associate professor at Northumbria University, used Webb's near-infrared spectrograph to observe Neptune in a way no previous instrument ever could. The team was searching specifically for a molecule called H3+, a charged form of hydrogen that has been used to study aurora activity on Jupiter, Saturn, and Uranus for more than 3 decades. On every other giant planet, this molecule had been a reliable signpost, pointing directly to auroral activity. On Neptune, despite repeated attempts, it had stayed frustratingly elusive, exactly as models predicted it should be present, yet somehow never actually detected. Using Webb's exceptional near-infrared sensitivity, the team finally found it, along with distinct infrared auroral emissions glowing on the planet, confirmed for the first time in the history of astronomy. As Heidi Hemmel, a co-author on the study, put it, only an instrument as powerful as Webb finally made this confirmation possible, after decades of trying and failing with everything that came before it. The observations themselves were captured on June 22, 2023, using Webb's near-infrared spectrograph's integral field unit, examining 2 different regions of the planet separated by 172 degrees of longitude in order to capture both hemispheres in detail. The team focused specifically on a narrow slice of the infrared spectrum, between roughly 2.87 and 5.27 micrometers, precisely the range where H3+ produces its distinctive low vibrational emission lines. It was painstaking, highly targeted work, built on decades of understanding exactly what signature to look for and exactly which wavelengths would reveal it, finally paired with an instrument sensitive enough to actually detect a signal that every previous telescope had simply been too limited to catch. The image itself, later combined with a full-color view of Neptune from the Hubble Space Telescope, revealed something genuinely strange. On Earth and on the other giant planets, auroras cling to the poles, glowing curtains wrapped around the top and bottom of a rotating world. On Neptune, because its magnetic field is tilted so drastically away from its rotation axis, the auroras don't line up with the poles at all. They appear scattered across the planet in unfamiliar patches, following the crooked geometry of that unusual magnetic field, rather than the more familiar polar pattern we're used to seeing everywhere else. It's a visual reminder that Neptune doesn't just look different from the other giants. It behaves fundamentally differently, its entire magnetic environment tilted and twisted in a way found nowhere else among the planets we've ever studied. But the Aurora discovery, remarkable as it was, wasn't even the finding that left researchers most surprised. While analyzing the same data, the team used Webb's instruments to measure the temperature at the top of Neptune's atmosphere for the first time since Voyager 2's flyby back in 1989. What they found left Malin, by his own account, genuinely astonished. Neptune's upper atmosphere had cooled by several hundred degrees since Voyager 2's visit. Specifically, the temperature measured in 2223 came out to just over half of what Voyager 2 recorded 34 years earlier. A planet already among the coldest places in the entire solar system had somehow gotten dramatically colder still, and nobody had seen it coming. Sit with that number for a moment. Half? Not a small statistical fluctuation, not a rounding, difference explainable by measurement error, but an upper atmosphere measuring roughly half the temperature it registered just over 3 decades earlier. For comparison, imagine checking the temperature of your own house today and discovering it had somehow dropped by half compared to a reading taken a few decades ago with nobody able to point to an obvious single cause. That's roughly the scale of the anomaly researchers found themselves staring at, on a planet already sitting in one of the coldest regions of the solar system, somehow still capable of getting dramatically colder without any external event triggering the change. That cooling turned out to explain the very mystery the mission had set out to solve in the first place. Astronomers had long predicted that the intensity of Neptune's aurora should be directly tied to the temperature of its upper atmosphere, with a warmer atmosphere producing brighter, more easily detected auroral activity. As Neptune's atmosphere cooled dramatically over the decades since Voyager 2's flyby, its auroras would have faded correspondingly, growing fainter and fainter, right up until they became too weak for any instrument before Webb to reliably detect. In other words, the very reason this discovery took 36 years wasn't a failure of earlier observatories. It was that Neptune itself had been quietly changing the whole time, growing colder and dimmer in ways nobody was tracking, closely enough to notice until Webb's data forced the comparison. That finding connects to a broader pattern researchers had already started to suspect. A 2022 study led by fellow Leicester researcher Michael Roman, using 20 years of accumulated ground-based data, had already identified dramatic stratospheric cooling happening on Neptune over time. Webb's 2023 measurements independently confirmed that trend and gave it a far more precise, more startling number to work with. What makes this genuinely remarkable is the distance involved. Neptune orbits more than 30 times farther from the Sun than Earth does, receiving only a tiny fraction of the sunlight and warmth that reaches our own planet. And yet, despite sitting in one of the coldest, most stable regions of the solar system, its upper atmosphere is still capable of shifting dramatically over the course of just a few decades, proving that even a world this distant, this cold, and this seemingly unchanging is still an active, evolving system, not a frozen, static relic simply waiting to be photographed. The research team's own published analysis, appearing in the journal Nature Astronomy, noted something equally significant about the timescale involved. Neptune's seasons last roughly 40 years each, given its enormous, slow orbit around the Sun, and the Sun's own 11-year activity cycle should, in theory, be one of the primary factors influencing atmospheric temperature this far out. But the scale and speed of the cooling Webb detected happened faster than either of those two processes could fully explain, suggesting that whatever mechanism is actually driving Neptune's temperature swings operates on a timescale shorter than both its seasons and the solar cycle combined, a genuinely open question researchers are still working to untangle. None of this would have been possible without the same instrument responsible for some of the clearest, most detailed images of Neptune ever captured. Webb's imaging of Neptune, first released back in 2022 and refined further with follow-up observations since, revealed the planet's faint ring system with a clarity not achieved since Voyager 2's original flyby more than 3 decades earlier, along with several of its 14 known moons visible in the same frame, including its largest moon, Triton, blazing with diffraction spikes bright enough to nearly overwhelm the planet itself in early images. Because Neptune's atmosphere is dominated by methane, which absorbs red and infrared light. Rather than reflecting it, Webb's infrared images show the planet looking dramatically different from the familiar deep blue captured by Voyager 2, appearing instead pale and almost ghostly, a visual reminder that the calm blue marble most people picture when they think of Neptune is, in Webb's infrared eyes, a completely different-looking world. Put together, these findings from a single set of Webb observations transform Neptune from the most poorly understood planet in the solar system into one of its most actively studied. A 36-year-old prediction was finally confirmed. A mystery about why that confirmation took so long was solved. And in the process, scientists discovered that this distant icy giant is changing in ways nobody had fully appreciated, cooling dramatically over a few short decades, its aurora dimming right along with it, all while sitting nearly 3 billion miles from the sun. Every one of these threads, the missing aurora, the unexplained cooling, the tilted magnetic field scattering light in unfamiliar patterns, ties back to the same underlying truth. Neptune has never been the quiet, unchanging world its distance from the sun made it easy to assume it was. For a planet most people rarely think about, sitting quietly at the edge of the solar system, Neptune just proved it still has secrets worth chasing. Its aurora, hidden for 36 years, finally confirmed. Its temperature, plunging by hundreds of degrees in ways nobody predicted. And its rings and moons, now visible with a clarity we haven't had since Voyager 2 said goodbye to this planet back in 1989. Webb didn't just take the clearest pictures of Neptune ever captured. It proved that even the coldest, most distant world in our solar system is still full of surprises we're only now equipped to find, sitting in data that had been waiting, quietly, for an instrument finally sensitive enough to read it. If you want to be here the next time Webb turns its instruments toward the outer solar system, subscribe and turn on notifications, because if Neptune was hiding secrets this significant in plain sight for 36 years, there's no telling what else is still waiting out there to be found.